Would you like to know about the storage options available in cloud computing? If so, this video is for you. We're excited to announce our new Get Hired interview program. This program will be available on Monday, November 15th. You can get this program now at our introductory pre-launch discount at 50% off by entering the coupon code Get Hired. The link is in the description below. Hi, my name is Michael Gibbs and I'm the founder and CEO of Go Cloud Architects. And we're an organization that's dedicated towards building high-performance cloud computing and networking careers. Personally, I've been working in technology for over 25 years, and I've been helping others get their first tech job or get promoted in tech for 2 decades. Today, we're going to talk about storage on the cloud. Now, today we're going to be using terms that are appropriate for AWS. But mind you, we're going to be talking about block storage and object storage and file storage. And while we'll talk about terms that are useful on AWS, please understand that if you're on Azure, if you're on Google, if you're on Oracle, it's the same service. The only thing that's going to change is the names. So the first thing we're going to do is we're going to talk about the storage and the storage types of block storage, object storage, and file storage. Then what we're going to do is we're going to talk about the AWS implementation of these and how they work. And then we'll have a lab for you to configure some of these options. So to begin, what is storage? Realistically speaking, storage is just where the organization's going to keep their data. Now remember, the whole point of all these applications, half of these servers, is to collect data. So the data is going to be absolutely critical to business. So storage is a must. You must understand this. You must understand availability, durability, and redundancy in your storage, and we will cover it. We're also going to cover the concept of volatile storage and non-volatile storage. So let's talk about that first. Volatile storage is storage that goes away when you reboot your server. So typically on a computer, we have things that are in memory, like RAM, random access memory. If you reboot your computer, they go away. And in a traditional data center, that's kind of one of the few things that goes away with reboot, but everything stays. But when we're on the cloud, it's a little different. When we're on the cloud, we have virtual machines. If you're on AWS, they're called EC2 instances. If you're on Google, they're called compute engine instances. If you're on Azure, they're called virtual machines. It doesn't matter. And they all typically have a local storage that's with them. That's called instant storage or ephemeral storage, whatever the case you choose to call it. That storage that's associated with the virtual machine goes away when you reboot, meaning it doesn't persist. And that's why it's called volatile storage, meaning it doesn't persist past a reboot. By comparison, when we talk about non-volatile storage, think of the things that are stored on your hard drive. You reboot your system, it comes back and it still has its storage. So when we talk about the concept of storage, we'll talk about the concept of volatile storage, or storage that goes away, and we'll talk about non-volatile storage, or storage that passes a reboot. Now when we talk about storage in the cloud, it's all going to fit into the following categories: block storage, object storage, and file storage. We'll begin by discussing block storage. Block storage is a type of storage area network. So for those of you that have ever been in a data center, and basically you see these RAID arrays that are filled with hard drives, and then you typically have a network, maybe some fiber channel cables and fiber channel switches and special cards that plugs into a server, that's typically block storage. But here's the thing about block storage in the storage area network. You take your data, you break them down into blocks, and each block has a block identifier. And that's, realistically speaking, how you're actually pulling the data based upon the block identifier. Now, when we talk about storage in the cloud, the storage that we're going to be talking about that's going to be attached to our servers is, typically speaking, going to be block storage. And block storage is a unique kind of storage in that it feels like regular storage, even though it is not. It is network-based storage. So when we talk about block storage, we'll talk about the performance limitations and a few other things. Understand block storage is network storage. And because block storage is network storage, it's going to be dependent upon the speed of the network to get to it. Why do organizations like cloud providers love block storage? Why is block storage used so widely? Because what makes block storage efficient is, let's say you've got a storage environment spread throughout your data center. You can store your data or your blocks anywhere where it's most efficient. So block storage effectively decouples the storage environment from the compute environment. So in a cloud provider, when you're dealing with the server and you need a hard drive in that server to look and feel like a real hard drive, we're going to be using block storage, and we'll talk about that much more later when we talk about elastic block storage. But just from a high level, understand that block storage is a storage area network where data is broken down into blocks. It scales very well because blocks can be placed wherever, so it's highly efficient. Now let's talk about object storage, because this is going to be used in the cloud computing environment everywhere. When you're dealing with object storage isn't regular storage. Object storage is another kind of storage area network where your data is taken and it's broken down into objects. Now, so far that sounds like block storage, and to this point it is, but here's where it differs. When the data is broken down into objects, each object is going to have an identifier or an object ID. Now, along with that, there's going to be some metadata that's associated with that object. Now, that metadata, or the data about the data, is going to describe that object. And because of this, object storage is rich with metadata. Because object storage is rich with metadata, it can be used for an incredible number of things. We can do things like run SQL queries on the data that's associated with an object storage environment. Think data lakes in the future. Think about looking and searching for parts of an object because it's got metadata. So object storage, highly useful, highly searchable. Now, when we talk about object storage, and we'll talk about the flavors of object storage coming soon, you got to remember, object storage is not regular storage. Object storage is used for files that are static and don't change. So if I want to distribute software, I pop in an object storage and I can submit that or distribute it to lots of people. It is brilliant for that. What is object storage bad at? Files that change. So with object storage, you can't put a hard drive on it, because think about the swap files and all these files that just constantly change. When you change files with object storage, it creates new versions. It'll fill up the storage arrays. So object storage is very useful for big data environments, for software distribution, video distribution, that kind of thing. And it's good for things that you write once and you read many times. Let's talk a little bit about file storage. This is going to be the simplest. Why? You're all familiar with it. In your hard drive, your computer, you've got a hard drive, you put your stuff in folders, that's file storage. You're in Windows, you mount to a file server, it's file storage. You're using a Linux system and you mount to an NFS share, again, that's file storage, just stuff that's broken down into files and stored. Standard file systems like NTFS on Windows or what have you, typical storage that you'll talk about. So now you know about block storage, object storage, and file storage. So now let's talk about some AWS storage types, and we'll begin with AWS Simple Storage, Amazon S3. And now what is Amazon S3? Amazon S3 is the Amazon branded object storage. So if you were with Microsoft, it would be called Blob. And if you were Google, it would be called Cloud Storage. And guess what? It's all the same. It's just the manufacturer's brand. Now, when we're talking about AWS, we're talking about S3. That's their form of object storage. Now, object storage on S3 is pretty great. It's relatively highly available, meaning it's 99.99% available, which means roughly 50 minutes of downtime per year when you need it, which is good availability. It wouldn't be considered extreme high availability, but it's good availability. Now, what we have here is the durability, which is availability is whether it's going to be there when you want it right now. Durability is going to be, is the data going to have its integrity? Meaning, even if I can't access it right now, the chances of it coming back and being perfect are related to its durability. Now, when you're dealing with AWS, the durability of your data is amazing. It's 11 nines durability, which is 99.99, and the 9 nines are counted out to 9 places. So we're talking about extreme, extreme durability, which means if you put your data on AWS, there's going to be about 45 minutes to an hour per year where you can't retrieve it, but you'll be able to retrieve it later and it's not going anywhere. 11 nines durability is absolutely amazing. That is some exceptionally good confidence you can have that your data is going to be there. So because S3 is not regular storage, it's object storage, let's talk about where you would use it. Backup and archival of an organization's data, static website hosting, distribution of content, media, or software. disaster recovery planning, big data analytics. Like I said before, when we're talking about AWS S3, we're talking about object storage. And the way it's going to work is you're going to have your data, and you're going to organize your data into a bucket. Now, each bucket's going to basically have a top-level domain space, and that means you can attach to your bucket via a DNS name. And you can give your bucket names up to 63 characters, and that's going to include letters and numbers and hyphens and periods. So keep that in mind. Now, architecturally, I want you to understand that object storage isn't like hierarchical storage, like file storage. It's kind of like a database, in which case you've got your stuff or your objects, and you've got a database that's got a pointer to the object. So kind of keep that in mind when you're thinking about object storage. It's not exactly regular storage, but it kind of works like regular storage. So again, object storage in a cloud environment, backup and archival, static website hosting, distribution of content, disaster recovery planning, or big data. So when you're coming to object storage, not going to be used by your servers. It's not regular storage, so just keep that in mind. So how can you secure your data? Well, you got a couple ways you can secure your data if you're keeping it in S3. There's two options. Option one is a bucket policy, which is basically using IAM, and you can get real granular on who can access what. Option two is you can do it based upon a computer version of an ACL permissions, which is read, write, or full control. Keep that in mind when you're using that. Now, other things to keep in mind when you're using AWS S3 is they've got multiple storage classes. And what do we mean by that? So let's think about an organizations and their usage patterns for their data. So, for example, sometimes people have organizations that have data that they use every day. Some organizations have data that they use every day for a short period of time, and then they use it a little bit periodically, and then they never use it again. So when we're dealing with storing our data on the cloud, we want to think about the usage patterns of our users. So we're going to walk through some storage classes with AWS. Mind you, it's just different pricing for different levels of availability, use, and whether you pay to access your data or it's already there. So it's about optimizing costs. So you as the solution architect or cloud architect are going to help the organization figure out the best place to place their data for maximum effectiveness while simultaneously achieving the minimum costs. So let's walk through the storage classes, which are going to be standard, standard infrequent access, standard infrequent access one zone. We'll talk about S3 intelligent tiering and S3 Glacier. Now let's talk about S3 standard. This is just standard object storage in the AWS cloud. It's going to be relatively high availability, high durability, high performance. And this is what you're going to use for data that you're going to send and pull. Send and pull. Why? It's designed like regular storage. All the features are enabled. So S3 standard is where you're going to put your data that you're going to access relatively frequently. Now let's say you've got data that you don't access frequently, but you still want to be able to use it. Now Amazon gives you this choice to have your data in an environment where you pay less for it, which sounds great. You pay less to store it there, but then you pay to retrieve it. And that's called S3 infrequent access. So think about this. You've got your data, you almost never use it, you can store it someplace, you pay almost 50% less, and oh, you need something, you pay a little fee. It could save you money. So for data that's infrequently accessed, Amazon S3 infrequent access, or S3IA, is great. But if you start to need a lot of this data, you're going to be paying a lot of retrieval fees, which could make it too expensive. So S3 standard for data you frequently access, S3 infrequent access for data that you don't frequently access, but you pay a retrieval fee. But you can get it the second you need it, you just pay a fee. Let's say you don't use your data very much, and you wanted to save further. Amazon has this concept of an S3 infrequent access one zone, and what that is, it's basically you pay to retrieve it, but it's also reduced availability. So instead of being in multiple data centers or availability zones, it's just going to be in one. So now you're getting even cheaper. But remember, S3 and frequent access, now you don't have high availability storage. So you pay when you need it. It's the cheapest, but remember, it's less likely to be there when you need it. So this may or may not be appropriate based upon an organization's needs. Now there's this concept of, AutoMagic. And when you're dealing with AutoMagic platforms, you're dealing with the vendor that runs typically a machine learning algorithm. and they monitor what's going on, and they kind of auto-magically move it around for you. And that's what AWS is doing when they start talking about intelligent tiering. They've got a platform, you stick your data on intelligent tiering, and Amazon automatically, their computer systems are going to move it to S3, S3 infrequent access, Glacier, which we'll talk about later. Basically, wherever it needs to be, basically S3 infrequent access. And then let's talk about the last thing that we'll talk about, which is Amazon S3 Glacier. What is Amazon S3 Glacier? It is an archive. It is a place where you put your stuff that you don't need for there a long period of time. So think about it this way. You've got your data, you access it a lot, you keep it on S3. You access it a little, you put it on infrequent access. Then you don't access it almost forever, but you want to know that it's there. If you need it, you put it in Glacier. So in Glacier, you're paying really low prices, and then you pay to retrieve your data. But if you need your data, it's going to take you 3 to 5 hours. And if you need to get your data faster, you can pay an extra heavy fee for the hour. So Amazon S3 Glacier is just low-cost storage archival. There's also an immutable vault option. Let's say you're in the medical world or the finance world and you have to store something for long periods of time. You can put it in something called S3 Glacier. It has a vault lock option, which means once you lock it down, no one can access it or modify the files. Great place to store medical records, financial records for your customers. Now in this example, what you can see on the screen is we've got data and we put it in S3. Now let's say we use that data every day for 30 days. So we keep it in S3. Now let's say we create a lifecycle policy. Let's say after 30 days, we infrequently use that data for another month. So you can see we're here on S3. We use a lifecycle policy to automatically move it to infrequent access after 30 days. And then after 30 days, we never use it again. So basically we create another policy to send it to Glacier, and now we've got it stored for long-term archival purposes. So now you kind of get an idea of the lifecycle policies, things that we can do. Now you'll recall where I told you that object storage itself is not suited well for files that change frequently. And that's because object storage by nature creates new versions every time things are done. Now, because this would fill up your environments, the cloud providers don't make you have 1 million versions of all your data unless you want them to. So AWS enables you to enable the natural versioning function of object storage by turning on something called S3 versioning. And what does S3 versioning do? Every time you modify an object, it creates a new version, which is kind of the default function of object storage in the first place. AWS had to do some workarounds around this to not do this. So this is just going back to standard object storage, touch a file, or modify a file, it creates a new version of it. And as you can see in this graphic, we've got a document we wrote. Every time we do it, we've got another version. So versioning in object storage is a great way to keep records and protect yourself from catastrophes. Now let's talk a little bit more about S3. You've got the option, and we strongly recommend using multi-factor authentication delete. What is multi-factor authentication delete? I'm going to tell you right now. You go to delete something, it sends you a challenge. You then provide a token or a one-time password, and the object is deleted. So I want you to think about what a cool optimization this is. Hacker gets into your systems, tries to delete something. You get a message on your phone, and then he or she is blocked from deleting it. So this multi-factor authentication delete is a very good thing from safety. Now we'll talk a little bit more because we're going to kind of go deep dive into these storage options, and let's talk about, organizing your data on S3. So you'll recall I told you S3 is not hierarchical storage. It is flat storage. It is just like a database. Basically a pointer pointing towards your data. Now we humans, we don't think in pointers towards the data. We think in slashes in this direction and slashes in this direction based upon whether we're a Windows user or a Unix user, Linux user, what have you. So when you're dealing with S3, you can organize your stuff with a delimiter. For example, I could do Mike/2021/AWS videos/storage/S3.mp4 for this video right now, if I chose to, and I could store it in S3 and it would look and feel like a folder, but remember, it is not. Now let's talk about protecting the data that's stored in AWS S3. Well, if you're going to store it, you probably should protect it. And realistically speaking, there's a couple ways you can protect your data. Encryption is going to be one of the best ways to protect your stored data. And when you encrypt your data, you've got 2 ways to do it. You can do it on the client side, or You can do it on the server side, and we'll talk more about that. But what is the encryption and what is the point? If I've got a hard drive that's got stuff on it that's valid, and I encrypt it, it's useless to someone that doesn't have the decryption key. So in other words, I'm in my home, I've got a bunch of servers in my home, all my drives are encrypted. Why are my drives encrypted? If some bad actor comes into my house and steals all my servers and my hard drives, they don't have the decryption key, they can't use it. So, but just remember, that's what encryption does. It protects your data. So while we're going to talk about encryption, let's talk about the encryption options on S3. We've got the SSE-KMS system. And realistically speaking, this is customer managed keys with the AWS key management system. And this is going to be a complete key management system. Basically, the users are going to manage the master key, AWS will manage the data key, and the key management system will provide a nice audit trail of who and when accessed the data. So this is basically going to be called SSE-KMS, and it's the customer managed keys with the AWS KMS system. Now, when you're dealing with this, you can also use the SSE-S3, and that's AWS managed keys. And this is a complete key management system. Again, the key management system is going to manage everything. It's going to do automatic key rotation, and every object is going to be encrypted with a unique key. So this is a relatively simple system, but remember, not every organization is allowed to have somebody else manage their keys. There are some organizations that must have complete autonomy over the keys, and with this, we're going to use the SSE-C, which is customer provided keys. And this gives the customer complete autonomy over their encryption key, but then again, the customer is going to have to manage all aspects of the key. Now, let's just talk about two more things with regards to S3. We'll talk about the concept of pre-signed URLs, and we'll talk about the concept of multi-part uploads. Pre-signed URLs. So once you put something in S3, and it's going to be private, which is a really great thing. So if you want someone to access it, you're going to have to enable access. And there's lots of ways you could do this, but the simplest and most elegant solution is to just create a pre-signed URL and send the URL. So basically what you're doing there, you're creating and signing the URL with your own encryption key. And this is going to provide temporary and secure access to the content. Now, when you're dealing with a pre-signed URL, it's temporary. So for example, let's say you sign it with your IAM instance profile. It's going to be solid for 6 hours, up to 6 hours before it expires. You can sign it with the AWS Security Token Service, and that pre-signed URL will be valid in up to 36 hours based upon the timeout that you set. You can set it up with an IAM user, in which case it's good for upwards of 7 days. And of course, you could set it up with a temporary token, and that means it's going to be good until the token expires. Let's just cover one last thing with regards to S3, and that is with regards to multi-part uploads. So when you're dealing with S3, you can upload some pretty big files, up to 5 gigabytes. But a lot of these files are going to be delivered via the internet, and a lot of them are going to be deployed even over the network. Now, when you're dealing with large files and network delivery, lots of stuff can go wrong. So in other words, let's say you basically sent 4.9 gigs of data over the network, and those last couple of bits get corrupted, and you tried to send a 5 gigabyte file. You lost it all. So AWS recommends that when you're dealing with S3, you use something called the multi-part upload. So if you want to upload a 5 gig video from your desktop to your S3 bucket, basically use something called the multi-part upload. What happens is you take your file, the file gets split into little mini parts, they all get sent up to the cloud, they get reconstituted back as one single piece, and then they get put in S3. So, now you know that. Now, I'm going to talk very briefly about instance storage. And the reason I'm going to do this is we're going to get into these other storage options like block storage and network storage. So let's just cover instance storage real quick. When you set up a virtual machine on your cloud provider, call it an EC2 instance, something from Google Compute Engine, something for Azure, like a virtual machine, it has this storage that's attached to the operating system that it boots with. Now, I want you to understand, this is the storage that's on the server. This is fast storage. Very fast, much, much, much faster than EBS volumes, faster than object storage. The only problem is, on a reboot, it all goes away, so you obviously can't store anything there. So now let's talk about elastic block storage. Elastic block storage is block storage on the AWS environment. Now, remember, block storage looks and feels like regular storage. It's not. Block storage is network storage, and the performance is limited by the speed of the network. But remember, block storage is good storage. It's good in that it can deal with rapidly changing files, so like an operating system or a swap file. It's good because it survives a reboot, and it's good because it's relatively good in terms of performance, and we'll talk about that. But most importantly, it's not deleted upon instant termination. And when you're dealing with block storage in the AWS environment, this is high availability storage, meaning it's 99.999% available. What does that mean in practical purposes? It means that you'll have access to your systems all but 5 minutes and basically 15 seconds per year. So that is good, high availability service. Now, block storage is, realistically speaking, the best performing storage you're going to get on the cloud. Now, this is not anywhere close to data center performance storage, but it's the best we're going to get on the cloud. And when we need high performance on a cloud, we're going to use block storage. Now, when you're dealing with AWS, remember, their versions of block storage, or EBS, is only available with a single availability zone, meaning it's in a data center. But also remember that your block storage is going to be backed up to another availability zone. Now, when you're dealing with block storage in AWS, you want to remember that it backs up your whole volume via snapshot. So if any of you have ever worked with backups, you know there's two ways you can back up your systems. You can back up your systems file by file and then restore them file by file, or you can back up your systems into an image. And the image basically is an exact bit by bit copy over what's on your drive. And basically you can take that image and restore that image to another system. That's exactly what goes on with EBS backups. They back themselves up, they image themselves in the form of a snapshot, which is placed on S3. So they have a very good, highly robust environment. So now the next thing is just regarding choosing the right type of EBS volume. So if you're going to use block storage, you need to use the right kind of storage. So let's talk about the kinds of block storage that exist. Basically, you can choose your performance type. Now, because I mentioned block storage isn't super performance oriented, but it's the best you've got, there's going to be multiple choices. Now, AWS thankfully just reduced a new form of storage called IO2 Block Express, and this is actually getting relatively good. It's AWS's highest performance form of SSD storage. It's relatively low latency, and it's designed for good high input-output workloads, like huge databases, like applications requiring low latency. Now, the throughput of this volume is pretty good. It's about 4,000 megabit a second, and the input-output operations of this volume, the IO2 Block Express, is relatively good, upwards of 256K. Now, I want to put it into context. You can go buy a Samsung 980 Pro drive for about $200 that's got about 500,000 IOPS. And that is less than $200. So this fastest drive you can get on the cloud is 256,000. So you're never going to get data center-like performance in the cloud on storage. In the data center, you could have 8 of these things literally sitting inside of a server in a RAID array. In the cloud, we could use RAID for these, but realize, realistically speaking, we're not going to get the performance of block storage that we can get in the data center, but we don't need it anyway. So understand, for 99% of all applications, this IO2 Block Express is high performance storage with good throughput and low latency because of high OPS. I just want you all to know this is getting closer to data center performance, but it's not quite there yet. Now, the next type of block storage we're going to talk about, which is what AWS calls Provision IOPS, or IO2. Now, AWS typically recommends this for basically databases that require high I/O, applications requiring low latency. Now, these are moderate performance. AWS would call them high performance. For the cloud, they're high, but they're moderate. You basically have 1,000 megabit per second throughput, which is okay. Going back to that Samsung 980 Pro drive that you could buy at Best Buy for $200, that will give you 7,000 megabit per second of throughput. This will give you 1,000 megabit per second of throughput. That drive from Best Buy will give you about 500,000 IOPS. This will give you 64,000 IOPS. So realize this is high performance cloud computing storage for the cloud, but it's still nowhere close to what you're getting in the data center. But it's more than you need for the majority of databases and other applications. The next 2 types of storage on the cloud are as follows. General purpose SSD, or GP2. Now, this is good, strong general purpose storage. It gives you a relatively decent balance of price and performance. It's terrific for a boot VM because it's going to stay after a reboot. It's going to have relatively good IOPS, meaning input-output operations, so relatively low latency because it's SSD, but lower than a provisioned IOPS. But the throughput on these drives is not great. It's about 250 megabit per second. A normal SSD drive is about 560 megabit per second. A really modern NVMe drive is good for about 7,000 megabit per second. So 250 megabit per second, you know, it's okay. It's not great. Perfect for transactional workloads, great for something you're going to do in a test or a development environment, just enough performance at a relatively good cost. Now, there are two other kinds of EBS VIMs as well. The next one is going to be something called throughput optimized hard drive. And basically, this is low-cost magnetic storage. Now, because it's low cost, it's going to be low IOPS, which means high latency. Now, the funny thing is these EBS throughput optimized drives have relatively good throughput at 500 megabit per second, almost as much as an SSD drive, because obviously they're using a RAID configuration. These are great for throughput intensive workloads, ideal when there's a lot of data to store and move, but low latency is not required. Great for large log storage, great for sequential reads and writes. Where can you think of high throughput, moderate latency video? If you're pushing around big videos, this would be a perfect kind of volume type, where a database would need high transactions, and those high transactions would be based on, you know, an NVMe-based drive like the provisioned IOPS volume. The last type of EBS volume we'll talk about is EBS cold hard drive, and this is going to be the lowest cost, the lowest IOPS, you know, moderate throughput, 250 megabit a second. Use this for stuff you're not going to access frequently. Now, while we're at it, we probably should cover the file storage types. And the file storage types are basically going to have one for Windows and one for Linux. The one for Windows is going to be file systems for Windows. And you know what that really is going to be? It's very simple. It's AWS managed Windows file servers. They run the server message block protocol. And that way they do Windows-based file sharing. And you've got all those same quotas and things that you get from Active Directory. Because you're dealing with Windows and Windows file servers, you've got encryption in transit, encryption at rest. AWS has a fully managed system for this, and it's called Amazon FSx. Of course, you could basically set up an EC2 instance, create a Windows file server, mount it to different storage, and share that as well. But this is a fully managed Windows file server. Let's talk about Linux Unix file systems. When you're using Linux or Unix or Linux, you don't use the server message block protocol for network file sharing like you do with Windows. You use NFS. So AWS has their own branded version of Network File System, or NFS, that was created by Sun Microsystems 1,001 years ago, that is now owned by Oracle. The AWS branded NFS, they call the Elastic File System. And basically that is just a file system that is designed to work with Linux and Unix systems. Of course, you've got two versions. You've got the standard version, which is normal high performance for stuff that you access frequently. And you've got infrequent access, just like with object storage, for things that you don't need that frequently. Now, with this, you've got two performance options. You've got burstable, which basically means you have a certain amount and then you can use a little more for short periods of time. Or you've got provision throughput, which is basically you know what you're going to need ahead of time. You tell AWS and you pre-provision it. And when you pre-provision, you get great performance. Key things to remember about EFS, given that it's so much like NFS, it's POSIX compatible, which means it'll work with your legacy systems. It's highly scalable. And one great thing that I love dealing with EFS is it's elastic. It auto scales. So you never really run out of storage capacity. And I got to tell you, I've been in an environment where not running out of stuff is amazing, not running out of storage. So there you have it. We have covered the types of storage. We covered block storage, object storage, file storage, and we covered the AWS implementations of those storage. Now at this point, we're going to go configure some of these things in the lab section.
In your AWS Management Console, click on S3. Click on Create Bucket. Now name your bucket. Choose your AWS region. I'm going to leave it as is. Scroll to the bottom and create your bucket. Now, to add a file to the bucket, click on the bucket, click on Upload, click on Add Files, and select the file that you'd like to upload. Now all that you have to do is click Upload. And that's all there is to it. Creating an S3 bucket and uploading files to that bucket is quick and easy. From your EC2 dashboard, click on Launch Instance. We'll choose a free tier, Linux AMI. We'll choose a free tier instance type. Edit the security group. Select an existing security group and go with the default VPC security group offered by Amazon. Click on Launch. We'll need to create and name a new RSA key pair. Now we'll need to view the instances. We need to wait for the instance to get up and running. We also need to wait for the status check to be done. This process takes a few minutes. Now that it's done, we'll need to generate our key pair so that it's accessible to PuTTY. Click on Load and go down to the file type and look for all files. There's the .pem file. Select it, open it, click OK. Save it as a private key. And for this tutorial, don't set a passphrase. Name it and save it. Now we'll open PuTTY to SSH into the instance. Click on the instance, click Connect. Now copy the instance's public DNS. Paste that into the hostname in PuTTY. On the left-hand side, expand SSH. Click on Auth for authentication. And here we'll select the key pair that we generated. And for convenience sake, we'll save this configuration so that we don't have to perform this step every time we try to SSH into the instance. Click Accept. And the first thing we'll do when we connect to the instance is perform a sudo yum update. We'll sudo the disk file system command with the H switch. This way we can see the available volumes associated with the instance. Now we're going to mount a volume to the instance. Please take note of your instance's availability zone. Now click on Volumes. We're going to create a volume. For this example, I'll create a 10 GB volume. Make sure you choose the same availability zone as your instance. Add a tag and name your volume. Create the volume. Now attach the volume to your instance. Once that process is complete, we'll perform the same disk file check. You'll notice that the newly attached volume doesn't appear. However, you'll see it when you perform the list information about all available block devices command. And now, we'll check the file type of the newly attached volume so that we can mount it. As you can see, there's no file system for the newly attached volume. We'll make the file system so that we can mount the new volume. Next, we'll use the make file system command. As you can see, we just made the file system. Print the working directory so we know where we are. I've changed directory to the home directory. Now I'm creating a parent directory for the volume. And next, I'm actually mounting the volume. And now by viewing the disk file system one more time, you'll see that the newly attached volume has been mounted. We'll double check this information by viewing the instance. Click on your instance and view its storage. It may take a few minutes for your newly mounted volume to appear in your instance's storage dashboard. And as you can see, the volume has been successfully mounted.
Thank you so much for watching this video on cloud storage. In this video, we covered block storage, object storage, file storage, and we covered the AWS branded versions of these. We covered AWS S3, we covered AWS EBS, we covered AWS EFS, we covered the file system for Windows. Hope you've enjoyed this video very much, and I look forward to seeing you in another video very soon. It was so nice having you join us for this video today. Let me tell you about some free services we do for the cloud community. Once per week, we actually have a free question and answer session live on YouTube, where you can come and ask us any questions you want about building your career related to cloud computing or networking, and we'll answer them in real time for you because we want to get you to your goals. Several more times per week, we have guests from industry experts that I've known for decades that are movers and shakers that have changed the world, that can give you information so you can build the best career. I invite them periodically. They are on my show. If there's a chance to do some free training on our channel, we'll do it live because we want you all to have the best skills for the best career. So please subscribe and hit the bell. I look forward to seeing you, and I look forward to assisting you in your technology career. Thank you so much. This is Michael Gibbs from Go Cloud Architect.